All right, let's continue to graph. Here's part 2. Can you graph this? What are the steps? So first, we need to factor this. So I'm going to see if it's factorable before I do anything else. If it's not factorable, I'll create a list. But if you factor out an x squared, you're left with x minus 3. If you factor out a negative 1, x minus 3. So it is factorable. I'm going to write it right here underneath that we have. In fact, I'll do it right here. So we have x squared minus 1 and x minus 3. Now, x squared minus 1 is a difference of squares. So you can square root each one and get x plus 1, x minus 1. And then the last factor is x minus 3. So now you have both. You have this expanded and you have all the factors. Now we can write down the 0. So remember, factors and zeros are opposite numbers. So negative 1. The exponent is odd, and that means it's going to cross. The next one is positive 1. Again, the exponent is odd, it's going to cross. And then the last 0 is 3. Again, the exponent is odd, it's going to cross. So at each one, negative 1, positive 1, positive 3, it's going to cross at each one. The leading term is x cubed, which means it's going to go up to the right. And then as x approaches negative infinity, the left-hand direction, it's going to go down to the left. The y-intercept is always that last number, which is 3. This last one we'll save for the end. I'm going to do this in red. So we have negative 1, we have 1 and 3. We also have the y-intercept at 3. And again, you should pause and try it first, right? But go up to the right and go down to the left. So this is what we know so far of the graph. So we have an empty point somewhere that we need to find, and that's at positive 2. So we're going to use at 2. I'm going to evaluate at 1, negative 3, negative 1, and 3. Just double checking to make sure I did it right. All right, so I got negative 3. That makes sense, how the graph flows. And then I'm going to connect the rest of the graph, and there it is. The maximum, this graph rises, and then the exact point where it changes and falls, where does it turn, is my maximum there, which is at 0 and 3. And then, as you follow the graph, as it goes down and turns again, and instead of falling, it rises. What's that exact point where it changes from falling to rising? Where does it turn? That's at 2 and negative 3. All right, let's do it again. This one is not going to be factorable because there are too many terms. So the list is small though. I know there's not a lot of room. In fact, I'm going to do it underneath here. There's a little bit more room underneath here. It is what it is. So we have 1, negative 4, 2, 4, and negative 3. From the list, I'm going to pick 1. We can pick another number too. In fact, what's left is actually factorable. So we have x cubed minus 3x squared minus 1x plus 3. That we could factor this by factoring out, look at the first two terms, factor out an x squared. Look at the last two terms and factor out a negative 1. And so they share x minus 3. X squared, take away 1, again, is a difference of squares. So if I write down the factors, this positive 1 as a factor is really x minus 1. We already have an x minus 1, so together this x minus 1 and this one together makes it squared. So there's my factored form, and there's my full. So I have a factored version and an expanded version. So the zeros are 3, negative 1, and positive 1. 3 and negative 1 are odd exponents, which means that those it's going to cross. At positive 1, it has an even exponent. So that's even, so it means it's going to bounce. The leading term here is x to the 4th, which means both ends are going up. So as x goes to infinity, the function goes up. As x goes to negative infinity, the function goes down. Oops, up. Both go up. There it is. So the both ends go up. Do a little picture for yourself if you want to. And now we're ready for the graph. So we're going to start at 3 and at negative 1 and positive 1. Oh, the y-intercept, that last number is negative 3 when you plug in 0. And again, both ends go up. So this is what we know so far. Now I'm going to plug in. The one spot that's missing here is at 2. So I'm going to do up here. I already have that divide sign. So at 2, I'm going to plug into 1, negative 4, 2, 4, negative 3. So I'm going to use synthetic substitution here at 2. And I get negative 3. Let's just make sure I'm right. So I get negative 3. I think that's right. And then connect the rest of your graph together. And then see how it matches what we said, and then we'll talk about the turning points. So we said at 3 and at negative 1 it crosses over, but at positive 1 it bounces. So do you see how it just touches and then stays and it bounces off of it and it doesn't cross over? So it matches, which is nice. We have a high turning point there where it bounces at 1, 0. So first of all, it goes down and then turns up. So what's the point where it turns up again? That's a low point. That's at 0 and negative 3. It rises and then changes direction again here. That's our 1, 0. And then at the last again, it goes down. And then when it changes going up, that point where it changes direction again is at 2 and negative 3. And there's your graph. All right, here we're just going to do some dividing together. So synthetic division and long division. So where I can do synthetic, I will. The second one, I can't do synthetic. I have to do long division. By now, this should be really comfortable, I think. And then do the work. There's no remainder. So how would you write the answer? So it's x cubed. So our answer starts with x squared. And then minus 3x minus 5. All right, long division. Make sure you don't forget the zeros. Double checking I didn't forget the zeros there. Okay. So we don't have an x squared, but we need to include it. And then we're just dividing the first term and the first term. That's it. So 2 divided by 2 is 1. And x cubed divided by x, subtract the exponents, just 1x squared. And then we multiply. X squared times 2x, x squared times negative 4, and then subtract. Be careful. When you subtract a negative, you're really adding. So it's 0 plus 4. And then bring down the next term. And then again, divide the first term and the first term. 4 divided by 2. Subtract the exponents and then multiply. And you get 4x squared minus 8x. That's no remainder. Bring down negative 8x. You can bring down 7 too. First term and first term divide. That's negative 4. Oh, I already brought negative 8x down, didn't I? So I already brought negative 8x down. Shush, right? That's no good. So when I do that, it's 0. So the only thing to bring down is negative 7, which means that's it. So our answer is x squared plus 2x. And then the remainder, which is negative 7 over what we divided by, 2x minus 4. There we go. All right, can you do synthetic substitution? We just did it for the graph, right? At 4. So can we do that substitution and evaluate this way? Again, you should do it first, right? And then see if you did it right. Just double checking. Make sure my brain can work here. That's negative 23. And you have your answer. Use the factor theorem to see if x minus 4 is a factor. How do you know if it's a factor? Take the 0. So x minus 4, the 0 is positive 4. And we want to see if the remainder at the end is 0. So this is how you show if it's a factor or not. And you can see, yes, it is a factor. And why is it a factor? Because 4 gives you a remainder of 0. So that is a factor of this equation. All right, use the rational zero theorem here to find all the possible. Now, for this one, we're just creating a list. So look at the very last number. So positive, negative 1, all the numbers that go into 28 evenly. You might have to take some time to think. I missed a number, 14. So all the numbers that go into 28 evenly, including 14. And then it says if 4 is a 0, use it to factor, find the remaining 0. So there's your gift. You're told 4 works. So I'm going to take the gift so I don't have to guess off the list. Make sure I'm doing it correctly. So it does work. And I'm left with x squared plus 6x minus 7. Then we're going to factor it the old-fashioned way. Two numbers that multiply to negative 7 add to 6. That's negative 1 and 7. They multiply to negative 7 add to 6. And then we write down the answer. So my goal was to find the zeros. So 4 was a 0. So the remaining zeros are positive 1 and negative 7. Done. All right, can you find all the zeros here and then classify them? So when it's in factored form, we're going to take each factor, make it equal to 0, and solve it. So each one I'm going to make equal to 0. I'm just going to solve them separately. So equal to 0, equal to 0, equal to 0, and just solve them. So x minus 4, add 4, and you get the answer 4. 4 is a rational 0. You know the exact value of 4. If you type it in a calculator, if you go to a number line, if you graph, you know exactly where 4 is. That makes it rational. Here we're going to add 3, and then we're going to square root. Now, when you solve a quadratic, the answer could be positive or negative, because when you square a positive number or square a negative number, you get the same answer. But the square root of 3, you can only approximate it. What number times itself is 3? We don't have that, right? It's a decimal that goes on forever. You can only approximate or estimate it. So that makes it irrational. And then the last one here, we're going to subtract 9. And again, we're going to square root. Now, when you square root a negative number, first of all, the answer is both positive and negative. But when you square root a negative number, it's imaginary. So it has an I for that symbol imaginary. And the square root of 9 is 3, because 3 times 3 is 9. And that are our imaginary zeros. So do you know the difference between an imaginary 0, irrational 0, and a rational 0? All right, some imaginary work. Can you multiply this out? We would draw a box, or you can FOIL. And we're going to multiply it out. So that's 20, that's 12i, that's 10i, and 6i squared. Remember that I squared is equal to negative 1. So 6 times negative 1, this is really negative 6. So once you do that, really think of this as negative 6. So 20 take away 6 is 14. And then 12 plus 10 is 22i. Adding, what's 5 plus 7? Got it. What's negative 4 plus negative 8? Got it. That's just adding complex numbers, combining like terms. Add the real numbers, add the imaginary numbers, and put it together. Here, simplify multiplying again. Now this one's a difference of squares, so I want you to see what happens when they're almost the same. One's adding, one's subtracting. So as you do this work, you'll notice that positive 12i and negative 12i cross out. And here you have negative I squared. Now remember, I squared equals negative 1. So this number, a negative times a negative, is really positive 9. So 16 plus 9, this answer is just 25, because the i's cross out. All right, so this is for honors and compacted math 2 in terms of doing it. So if you are in CP, you're good. You don't have to do this page. This will not be on the exam for CP. So can you simplify dividing? We're going to take that denominator and multiply top and bottom by the conjugate. And we multiply it out 4 times 3 and 4 times I. And then the denominator, 3 times 3 and negative I times I. And then we're going to simplify this down here. Remember, I squared is negative 1. So this is really 9 subtract negative 1. So when you subtract a negative, you're adding, and you have your answer. You do not need to simplify it. If you show me your work with imaginary numbers and leave it like this, I'll give you full credit. Here again, we're going to multiply by 3 minus I, top and bottom. It's a little trickier because the numerator is a full complex number, which means I have to FOIL the numerator out. So 2 and 3i and 3 minus I, and I got to multiply it out and fill it in. Make sure I do it okay. And then I'm going to come back here and simplify it. So this is 6 plus 3 and 9 subtract 2. That's good. That's 9 plus 7i. Then the denominator is just a difference of squares. So first times first is 9. And then second times second is I squared. We talked about I squared is really negative 1. So it's a negative times a negative. That makes it 9 plus 1. And 9 plus 1 is 10. And you have your answer. All right, Pascal's triangle. For some, this has been a while, but I'm going to show you Pascal's triangle. It's 1. You start with a 1 and end with a 1. And then you add the numbers above it. So we have 1, 1, 1, 1, 2, because 1 plus 1 is 2. Again, we're going to start with a 1 and end with a 1. We'll add the numbers in the middle, 1 plus 2 and 2 plus 1. So when we cube, this is the row we need. The second number matches the exponent. To the fourth, the next one will need the next one, so why not, right? Make sure that we're expanding this correctly. And then we have two terms, 3x and 2. So we're going to take this row, we're going to go 1, and then we're going to go 3x to the 3, and then 2 to the 0, plus the next one's 3, and we're going to go 3x to the 2, and 2 to the 1, plus, I'm going to run out of space here, make sure I have enough, 3, 2x to the 1 and 2 squared, and then the last one is 1, 2x to the 0, and 2 to the 3. So see the pattern of the exponents as you go down, and then you can try to simplify it. This is 27x cubed. Put the answer here. 9, 3 squared is 9 times 3 times 2, or 9 times 6, that's 54. X squared. This is 4 times 6, 24. That is 1. So this is 2 cubed times 1. 2 cubed is 8. And that's it. You've expanded it using Pascal's triangle. All right, last one there for Pascal. We're going to use the bottom row. So follow the pattern. 1, we start with Pascal's triangle, then x to the 4 and negative 3 to the 0. And then the next number in the triangle, 4. And then x to the 3 and negative 3 to the 1. And then 6, x squared and negative 3 squared. The next number is 4. Again, x to the 1 and negative 3 to the 3. And then the last pattern, 1 and x to the 0 and negative 3 to the 4. And then we simplify each one and have our answer. So any base to the exponent 0 is always equal to 1. So it's just x to the 4th. Negative 3 to the 1 is negative 3 times 4. That's negative 12x cubed. This is 9 times 6, that's 54x squared. That's 27 times 4, might be a little bit out of my brain right now. That's 28, that's 108. That's negative with the odd exponent. And then negative 3 to the 4, that's 81. Done. All right, last one, almost last one. What is a rational zero? It is an x-intercept. So it is a rational zero is an x-intercept you know the exact value of. An irrational zero is an x-intercept you can only approximate. And a complex zero is not an x-intercept, but is a number with an imaginary part to it that makes the equation zero. So we have a complex zero, not an x-intercept, but is a number with an imaginary part that we don't probably need to, so with an imaginary part that makes the equation zero. These two are x-intercepts, except one you know the exact value of and the other one you approximate it. All right, last part, can you find the zeros here? So we're going to create a list. We're going to go fishing and see if we can find. So I'm going to try -1. No, -1 doesn't work. Right? Did I do that right? As soon as I know it doesn't work, then I'm moving on. All right? Try 2. Doesn't work. I hope -2 works. Taking up all this paper. It's okay to have something fail. I don't want to fail over and over again. This one's got to work now. This one works. Man, it took forever. Okay, so -2. It says find the zeros. Well, we found 1 0. Sometimes you fail, and find it. What's left, we are going to complete the square. So we're going to make it equal to 0. X squared minus 4x plus 1 equal to 0. I'll just try to have room here for this one over here. To complete the square, we're going to take b, which is -4, and divide by 2 and square it. So -4 divided by 2 and square, that magic number is 4. So we're going to go x squared minus 4x plus 4 on both sides. And 0 plus 4 is 4. Then the first 3 terms are factorable. It's squares with -2 and -2. We're going to subtract 1, so it's equal to 3, and then we're going to square root. So this answer could be both positive and negative, and then add 2. A rational number and an irrational number are unlike, so they only go beside each other, and that's it. We found them. So if we summarize what the zeros were, they were -2 and then 2 plus and minus root 3. So -2 was rational and 2 plus or minus root 3 were irrational. All right, last one here. So my list 1, 2, and 4. Using common sense, a positive number will never give you 0, right? Because if I put in a positive number, it's just going to get bigger and bigger. It won't be 0. So I'm going to start with -1 and hope. Good, it worked. Thankful. So negative 1 worked. That's what's left over. X squared plus 2x plus 4. Again, I'm going to complete the square. So I'm going to go 2 divided by 2 squared. That's 1. I'm going to add 1 to both sides. So I'm going to go x squared plus 2x plus 1 to both sides. And again, 0 plus 1 is 1. The first 3 terms factor to x plus 1, x plus 1. And then I'm going to subtract 4 to get negative 3. And then when I square root, the square root of a negative number, again it's positive or negative, is imaginary. But root 3 is irrational. There's no number times itself. So we have an imaginary part with root 3, and then subtract 1, and you have your answers. So if I had room here for the zeros, I would say it's negative 1 is a 0, and then negative 1 plus or minus I root 3. And there you go. Hey, I am proud of you all the way to the end. Practicing, then you need to study what you practiced, right? And do the best you can. Your exam's going to be based on these questions. I believe in you. You're going to do great. Mr. G Math, until next time.